We were scheduled to break after Bob spoke, but since he allowed us the time to catch up, we're going to keep going for a little while. And so our next speaker, and I'm glad that you came on up, Mr. Modeen. Let me talk a little bit about you. Come on up here. Dave currently serves as Director of External Affairs for the energy power sector, where he has responsibility for managing communications and interactions with the DOE, Office of Nuclear Energy, Idaho National Laboratory, Institute of Nuclear Power Operations, Nuclear Energy Institution, and Nuclear Regulatory Commission of Research. Dave first joined Electric Power Research Institute in 2003 as a Vice President, Nuclear Sector, and Chief Nuclear Officer. He's also been a director at the NEI located in Washington. Prior to that, he had experience as a shift technical advisor at the Trojan Nuclear Plant. Dave is a graduate of Iowa State University, where he obtained a BS degree in industrial engineering and served in the U.S. Navy as a submarine warfare officer. Please join me in welcoming.
Good afternoon. It's certainly my distinct pleasure to be here. I'm often reminded that in our industry we talk too much to ourselves and not enough with other industries, other stakeholders, and I've certainly learned a lot today. And the one thing I learned was that I would have loved to have served with Bob Gallagher. I think he would have been a great guy, and I'm sure his salty tongue would have fit in very well with the on board the USS Patrick Henry. What I wanted to do today, let's see here. Do I just click? I have some PowerPoint slides if we could load this. Okay, great. To really talk about the future of nuclear energy in the U.S., but I think it's really a global perspective, and ask the question. You'll see in the agenda it says nuclear renaissance. I have the perspective of, is it a renaissance yet? And you can make up your mind after I'm done talking. 4 points I want to talk about, just a little bit about EPRI, or the Electric Power Research Institute, who I do work for now, and then a little bit about confronting the global climate change, greenhouse gases, CO2 emissions, carbon footprint, whatever you want to call that. Then what is a nuclear renaissance? I'll give you my definition, and then talk a little bit about our nuclear technology priorities. First point to make about EPRI, we are all about R&D collaboration. We are not an advocacy organization per se. However, we do a lot of work in the public interest in serving the electric sector of our economy and trying to inform the debate and try to get the right policies, but others put that forward. In fact, that company, the Nuclear Energy Institute that I worked for 14 years in Washington, does really handle that role for us, but we work hand in glove with them. I think the other thing to recognize about EPRI and our members is that, and I heard this from one of our member CEOs recently, that their companies stand at the center of reality and policy. And I think that rang true over and over this morning as I was listening to the issues relative to the oil and gas industry and the policy and the requirements. And yet, at the end of the day, the companies, the industry still needs to serve that need. And you'll see from this slide here that although we have, let me get my little button there. I used to run our nuclear power program. We actually have programs in all other forms of generation in one group. Power delivery, you can think of that as transmission, distribution. Utilization is end-use efficiency, energy efficiency. And we have a group of scientists that really try to help us sort through what about all these technologies that we're developing and improving, how does it play out in the public space, in the environment, and what's the synergistic effects back and forth. And then finally, the point I was going to make here is our nuclear power program is really about 40% of the EPRI portfolio. And then the mission of our sector is all about the existing assets. These are the current plants, 104 in this country, and involvement, participation by another 230 reactor units from around the world. And then looking longer term, supporting deployment of new technologies, whether that is the deployment of new nuclear power plants, such as what's being debated and actually plans moving forward in this country today, but then also looking at issues in the fuel cycle arena that I'll talk a little bit more about shortly. And to provide a perspective, I think just like the oil and gas industry, nuclear power really is an international game. Our company in 1973, when founded, only had U.S. participation. Beginning in 1975, we had loan-ins from the Électricité de France when they were trying to determine what technology to select for their program. I think many of you may know they now have 58 operating reactors, generate about 80% of their electricity from nuclear. And then over the years, we've added these others as full members, and then we have participants that are involved in one part of our program or the other. And then, so we definitely collaborate, we share funds, share information, share research, etc. So let me shift gears and talk a little bit about greenhouse gas emissions and rate reduction. This issue came to the forefront, I think, at EPRI in about 2003, 2004, as our member companies looked at and knowing that they needed to invest billions, hundreds of billions of dollars in new generating assets, new transmission distribution, and they were very concerned as to what they may invest in and how those investments may be obviated in a carbon-constrained world. And so we went about, especially with our environment sector, answering these three questions. Is it feasible to turn the emission rates of CO2 from the electric sector now in particular? And then, if so, what is going to be the impact? And can we do it immediately, or what sort of time frame might it take? And oh, by the way, everyone loves renewables. Can we do it on renewables alone? And then the last point, what are the challenges for deployment? This graph is a little hard to see, but basically this prism, and the prism refers to these colors, what we concluded, and I think it was said earlier again, I think it was Bob that talked about a portfolio of capabilities and resources to address liquid fuels. Similarly for electricity, what this map shows is a projection by the DOE's Energy Information Administration, and here we are in about 2008, and then what will the emissions of CO2 from power plants in this country look like given their reference case, their estimate of what technologies, what energy efficiency techniques, et cetera, will occur over between now and 2030. We did our own independent assessment and more aggressive targets, heavy lifts, but yet with the right policies and the right investment in technology, what we believe is feasible. I warn you, the one particularly heavy lift here, this orange one, is under here, this CCS is carbon capture and sequestration. What we're targeting is by 2020, the technology and the permitting and otherwise is in place. That's probably the one with the informed debate that is the most questionable as to whether or not it can take off at this point. Nuclear generation that I'll talk about here is this one yellow wedge, but you'll see we are not so foolish as to think that nuclear only can get the job done. What this little wedge represents here is 64 new gigawatts of electric by the year 2030. That's about 50 large-scale nuclear power plants in this country. We haven't started up any new ones since about 1995. Costs are difficult to estimate, and you've seen where costs for any large infrastructure project has accelerated tremendously. So that too is a heavy lift to add to the 100 gigawatts of non-emitting nuclear that we have today. The other thing, that was kind of a top-down that, in our view, if we developed the technology, had the right policies in place, could we turn emissions and the rate of emissions? Yes, we can. But then the other question was, what is the economic impact? This is just one slide of many sensitivity studies, not a prediction, but a sensitivity study, that if this full portfolio, what I showed on the other slide, was available in the time frames estimated from 2015 to 2020 to 2030, what would that portfolio look like in 2050? How emission-free might it be? and also what would be the cost of electricity in today's dollars. We basically concluded that without advanced technology, electricity will be more expensive in the future, no doubt about it. Technology will cost money, but if we don't get started now and we don't do something now, it's going to cost a lot more with if we have to turn from coal, if we do turn away from nuclear. And you'll see if you can, this is natural gas here. This is coal with carbon capture and sequestration, 2050, 2030 timeframes, and the nuclear wedge here. What our economic models, and we have economists, PhD economists on staff, they play in the international global climate change arena. Our MERGE model is one of 3 recognized by the United Nations. Again, tremendous uncertainties in that model, but nevertheless, it gives you a relative indication of what may happen in a very large macroscopic modeling of the United States as well as the world. And what my economists tell me is that we'll take all the nuclear we can get if, in fact, the infrastructure, the manufacturing, the personnel, the skilled craft, the welders, et cetera, are available. We have to limit our model so it doesn't just drive in that direction. So now I'm going to leave that and talk specifically the piece about global climate change, which was one of the drivers for nuclear, but really kind of step back and say, you know, it wasn't just in the last couple of years that there was interest in new build for nuclear energy in this country. And here are some of the reasons why. The first is that the current fleet of reactors, again, 104 reactors operating with an average capacity factor of 92%. That is, the entire fleet is online most of the time. And large baseload, tremendous amounts of energy, very stable cost of electricity, of course, emission-free. That wasn't always the case. The first part, our economic, safe, reliable. When I worked at the Trojan plant in Oregon, we were happy if we ran 88 days in a row. I remember getting a coffee mug because we ran the plant almost 3 months in a row. Today, if you can't run for at least 18 months breaker to breaker, if you're on that type of refueling cycle, or certain plants that are intended to run for 24 straight months, it's really been a bad cycle. You know, the industry has changed tremendously. Also, when we did this at EPRI, this point here of trying to capture the lessons learned with our members and the existing fleet, and again, the existing fleet worldwide, we spent a lot of time between 1985 and 1995 setting the groundwork for what should the next generation of nuclear power plants look like. The unfortunate thing was that although we built them in Japan, and they've been built there, and they're being built in Taiwan, and they're being built in Finland, we haven't yet deployed that technology here in this country. We're getting closer, but it's like we really know, I think, how to do it better this time than we did the first time around. But with the construction that has occurred in the operation, we're more confident that we'll do it well. Brownfield sites, this refers to those locations where existing reactors are already operating in this country, and there's capacity, there's transmission, there's water, et cetera, available to take more sites, or I'm sorry, more reactors there. So it should ease the types of environmental reviews and the siting issues. There are a couple plants planned where they did not exist before, and we're working through that as an industry and the companies. We'll see how that goes. And then you'll see here now we have over 30 reactors in various stages of applications to the Nuclear Regulatory Commission for approvals to actually start the construction project. These are big projects, long-term, on the order of 10 to 11 years, billions of dollars, and depending upon, and it's somewhat apples to oranges, but depending upon how you count the monies and what needs to be done at the site besides the reactor plant, $4 to $7 to $8 to $9 billion each one. But again, generates a lot of electricity once complete. The other piece, and it was commented earlier today, was we really do have some great incentives in the Energy Policy Act of 2005. Pete Domenici and Senator Bingaman were instrumental in that, along with a few other key senators and their leadership. I think the first 3 points here, and I won't go into the details, but the standby support, government guaranteed financing, production tax credits, all that was really trying to get over the inertia of companies that did not have a very good experience the first time around with nuclear plants from an economic shareholder equity investment rate of return experience, and they're relatively small companies compared to the size of these plants to try to get over some of those hurdles and really hedge the bet a bit, or the arbitrage. These other 2 points are really the nuclear R&D hydrogen projects. Price Anderson is all about really the long-term sustainability. Long-term, my view, is the year 2100. I'll talk about that in a moment. Nevertheless, it's not all wonderful. I was testifying last year before a National Academy of Sciences panel, and the gentleman asked me a question. He says, boy, your members must be ecstatic. They just must be excited about all this, interest in nuclear energy and going forward. And I said, well, I don't think they're ecstatic. I'd say it's more like a healthy, sobering skepticism. They feel compelled that nuclear is part of the answer, part of the solution, but yet a lot of healthy skepticism as to there's a lot of heavy work to be done. For instance, the whole regulatory process with the NRC, we believe it's better today, but once one has billions of dollars put into the ground, you really need to bring the plant online if there aren't any, if there are not any important safety issues. I'm trying to remember what Bob Gallagher's term was, the emotional obstructionist realized. We certainly had a history of that in the nuclear industry. We think we can avoid that this time. Nevertheless, it's of concern. Second point, and we see it everywhere in our life today, is the escalating costs, both labor, engineering, and materials. Infrastructure challenges. The U.S. industry today doesn't look anything like what it looked in the 70s, 80s, or 90s. This will be an international renaissance to get started, but we really need to do much more, and we are doing that in this country relative to workforce, the supply chain, the large components that we need to build. Spent fuel management, I think that's as much a political issue or obstacle as compared to a real one. There's significant interest in closing the nuclear fuel cycle, something the Bush administration started about 2-3 years ago to really say that, spent fuel isn't really spent. It's only a few percent of the energy is removed from that fuel, and we really need to take advantage of that long term, especially if we build many, many more plants. And then there is the issue of proliferation and rogue regimes and otherwise that, although it's not the industry's responsibility, we need to fit into the national and the global infrastructure that assures there is no proliferation of nuclear or weapons grade materials. So, let me ask you, does a nuclear renaissance look like this? I think it does. First of all, the current plants are poised toward extended operations. We worked for 20 years at EPRI with the Nuclear Regulatory Commission, the Department of Energy, and our member companies to set the basis and to show that those plants can run safely for 60 years as opposed to 40 and extend the licenses. We've extended the licenses of already half of the fleet, and the rest will do that as well. We have the public and policymakers' support today on all these factors that I note up here. We're about ready to add the new nuclear plants to the generation mix, but connecting to the grid will most likely occur in 2016. It's 8 more years at the earliest. And then we also have activities underway with the industry and government national labs and other industrial partners on other nuclear technologies to really supplant carbon-emitting technologies that are better used for other roles. Natural gas is a good one. We really don't want natural gas being used to generate electricity. And then that long-term sustainable infrastructure, basically the fuel. What about the uranium? What about the used fuel? Just a couple points here is from our work on the PRISM analysis, what became very clear is that the current plants are very, very important. We're going to work hard as a country in the next 15 years to try to have 64 gigawatts online by 2030. We have 100 gigawatts today. With that 60-year current license limit on those plants, they start coming offline in 2029. So then we're barely kind of keeping even. We add 64, we take off 100 over the next 20 years. We are working, and we started this last year with the Department of Energy and the Nuclear Regulatory Commission to say, what about 80 years? You know, what are the showstoppers? What are the issues? What do we have concerns about? We know that the last time around, it took us about 20 years to make the case to go from 40 to 60. Well, let's get busy. And then the second piece is this deployment of the advanced light water reactors. We anticipate we will have on the order of 10 to 12 new plants by 2020, but we need to be able to increase that build rate. Oops, I'm sorry, I got too many things in my hand here. I can't. From a standpoint of what does this mean for Lee County, New Mexico, and Hobbs in this conference, I put up this list of challenges. They deal with the actual reactor systems themselves, current plants, future plants. They deal with fuel. They deal with the workforce of tomorrow that we need, wherever these plants are located. And actually, we don't necessarily need them where they're located, but we need them where the supply chain is, where the manufacturing base will be. We also need to look at and work on the advanced fuel cycle and do it the right way. Again, I was reminded by the remarks earlier today that the wrong policies can have us going down many rat holes and not necessarily moving toward the ultimate proper solution that really the technology and the science might demand. I believe there is significant opportunity for this community in both research and development, manufacturing, and the training of tomorrow's workforce. Just one little cartoon to try to explain what integrated spent fuel management might mean. Up until 2-3 years ago, with the change in the administration policy, when we took fuel out of a nuclear power plant, after, maybe on the order of about 5-6 years in the reactor, the plan was to go put it in a geologic repository, not to be used again. There are some historical reasons for that, some government policy reasons. That is all changing. And the point is, how do we extract the good material that's still left in that used fuel? Good, I'll say fissile. That means we can fission it, we can create heat, much like we do in the reactors during the first 5-6 years. It's a difficult process to separate out the uraniums and the right plutonium isotopes, et cetera, but it can be done. But we need to move it from laboratory scale to large commercialization. These elements here are the areas of that plan and the right sort of research that needs to be in the demonstration projects. This is something that in our estimates, in concert with the Idaho National Laboratory, we think is about a $50 billion, and that's rough. It could be 30 billion, maybe it's 60 billion, and it's probably a 30 to 50 year program. Also, our models tell us that it's not something that needs to be solved tomorrow, but we need to be working on it more diligently today. And there's much debate, again, in the Congress as well as in the national laboratories and otherwise as to how to go about it. But it's something that, again, the right community with the right expertise can help inform that debate. And just a real quick one on the using nuclear energy, higher temperature gas reactors for hydrogen and process heat production. I think useful, but from our point of view, representing the electricity sector, not a very high priority. Nevertheless, the government and the industry is taking steps to further develop and test this technology such that we can commercialize it in about the 2025 timeframe. And let me just conclude by saying I believe, although I don't think we are at a renaissance yet, the outlook is very positive. I think it is technically feasible to slow in turn the rate of carbon emissions in the electricity sector, but meeting those future CO2 constraints will cost more in electricity. Nuclear energy will play a role. It won't do it all, though, and we need the whole portfolio. Thank you.